continue processing using diffusion. Ang example po na nandito ay doping silicon with P for N-type semiconductors. Ito po ang process. So, una po, deposit phosphorus rich layers on surface. Yung pinaka-surface po natin ay yung silicon. Tapos po, yung pong nasa taas natin kung saan po yung apat ay yung phosphorus. So, nung mahit po natin ito, nag-result po siya ng doped semiconductor regions. Ito po ay parang inabsorb po nitong silicon yung phosphorus dahil po sa heat. Kung makikita naman po natin dun sa unang picture, hindi po siya nag-absorb or nasa ibabaw lamang po siya. So dahil po ng heat, dun po naganap po yung doping. Ito naman po ay isang illustration po ng magnified image o computer chip. Ito po ay katulad lamang ng example kanina na about po sa doping. Ito pong light regions ng silicon atoms at aluminum atoms. Makikita po natin sa dalawa na parehos lamang sila, pero nagko-contrast sila sa isa't isa, kung saan ito pong dalawa ay nakakonekta sa iba't ibang transistor. Modeling rate of diffusion flux. So, how do we quantify the diffusion? So, ito po yung formula natin. Ang J po, or the flux, is equal to mass over area times time. Or kaya naman po, constant over area times the derivative of mass over the derivative of time. So, dapat po, magiging sagot natin ay pwede pong kilograms per meter squared second or atoms per meter squared second. So, ang flux daw po, it can be measured for vacancy, host A atoms, and impurity B atoms. So, it is empirically determined or na-examine po siya through make thin membrane of known surface area, impose concentration gradient, measure how fast atoms or molecules diffuse through the membrane. Makikita naman po din po sa isang graph. Ito po yung illustration kung saan pinapakita po yung relativeness po ng diffuse mass sa time. Magkakaroon po ng slope during time, at ito po yung tinatawag nating flux. Steady state diffusion, J gradient of C. Concentration profile po, ito po ay kilograms per meter cube. Ito pong concentration of copper and concentration of Ni ay parang magkaparehas, pero nagko-contrast po sila sa isa't isa. Katulad po ng example kanina about sa chip, yung aluminum atoms at silicon atoms natin kanina. So, dumako naman po tayo sa Fick's first law, kung saan gagamitin po natin mamaya sa pagsosolve po about sa steady state diffusion. So, ang Jx, ito po yung flux na hinahanap natin. Ito ay mahahanap po sa pamamagitan ng pagkahanap po ng diffusion coefficient, which is the D. Ito po ay constant at given po sa particular material na gagamitin po sa diffusion. Tapos po, yung dC over dx, ito po yung concentration gradient, na dapat ang sagot ay kilograms per meter raised to 4. So, the steeper the concentration profile, the greater the flux. Steady state diffusion. So, ang steady state daw po ay concentration profile not changing with time. So, makikita natin sa box, yung concentration natin or yung C ay hindi po siya nag-change dahil po sa time. So, ang steady state po ay equals to Jx of left is equal to Jx of right. So, by applying fixed first law, Jx is equal to negative t times dc over dx. If jx left is equal to jx right, then dc dx left is equal to dc dx right. So, magre-result po siya na the slope or the dc dx must be constant. So, slope doesn't vary with position. To continue po, rate of diffusion independent of time. So, kapag po linear, mas madali po nating maiintindihan pag makikita po natin yung pong pinaka-illustration po. So, dc over dx is equal to change in concentration over change of the distance of the diffusion. So, it is equal to C2 minus C1 over x2 minus x1. To summarize po, fixed first law of diffusion is equal to J is equal to negative D, which is the diffusion coefficient, times dc over dx. So, diretso po tayo sa problem solving. Meron po akong tatlong ipapakitang example na about po sa steady state diffusion. Madali lang naman po ito. Sana po maintindihan natin. So, example 1, chemical protection clothing. Methylene chloride is a common ingredient of paint removers. Besides being an irritant, it also may be absorbed through skin. When using, protective gloves should be worn. If butyl rubber gloves, which is equal to 0.04 cm thick, are used, what is the diffusive flux of the methylene chloride through the glove? Ang data given po natin ay D in butyl rubber is D is equal to 110 times 10 raised to negative 8. Tapos ang surface concentration po ay equal to 0.44 grams per cm cube. At ang C2 po ay 0.02 grams per cm cube. Ang diffusion distance po ay equals to 0.04 cm, which is given po sa problem. So, dito po, dun po sa may kulay na illustration, makikita po natin kung paano nangyari po yung diffusion. So, sa given formula po natin, flux is equal to negative D times C squared minus C1 all over X squared minus X1. So, flux is equal to negative 110 times 10 raised to negative 8 cm squared per second times 0.02 grams per cm cube minus 0.44 grams per cm cube all over 0.04. Nakakuha po tayo ng value na 1.155 times 10 raised to negative 8. So, ito po dapat ay may grams per cm cube sa huli. So, next example po. Example number 2, see diffusion in steel plate. Steel plate at 700 degrees with geometry shown. So, makikita po natin sa illustration yung mga given po. So, ang C1 po ay equals to 1.2 kilograms per meter cube at 5 millimeter. So, magiging 5 times 10 raised to negative 3m. Kasi po, diba, dapat naka-meter po kung kilogram or meter po yung nasa taas natin. At ang C2 po ay is equal to 0.8 kg per meter cube at 10 mm. So, magiging 1 times 10 raised to negative 2 meter. So, ang D po natin, which is the given diffusion constant, 3 times 10 raised to negative 11 m squared over S at 700 degrees. So, sa pag-insert po ng mga given value, magiging J is equal to negative D times C2 minus C1 all over X2 minus X1. So, magiging J is equal to negative 3 times 10 raised to negative 11 m squared per second times 0.8 kilograms per meter cube minus 1.2 kilograms per meter cube, all over 10 times 10 raised to negative 3m minus 5 times 10 raised to negative 3. Magiging 2.4 times 10 raised to negative 9 kilogram per meter cube. Example 3 po, diffusion of radioactive atoms. So, may given po tayo, surface of Ni plate at 1000 degrees contains of 50% Ni63 of radioactive and 50% of Ni, which is the non-radioactive. So, makikita po natin na steady state diffusion po ito. So, 4 microns below surface Ni63 over Ni is equal to 48 is to 52. Lattice constant of Ni at 1000 degrees Celsius is 0.360 nanometer. Experiment shows that self-diffusion of Ni is 1.6 times 10 raised to negative 9 cm squared per second. So, what is the flux of Ni63 atoms through a plane 2 micrometer below surface? So, ang C1 po natin is equal to 4 Ni per cell times 0.5 Ni63 per Ni all over 0.36 times 10 raised to negative 9 meter raised to 3 per cell. So, ang sagot po ay 42.87 times 10 raised to 27 Ni63 per meter cube. Ang C2 naman po natin ay 4 Ni per cell times 0.48 Ni63 per Ni all over 0.36 times 10 raised to negative 9 meter raised to 3 per cell. So, ang sagot po natin ay 41.15 times 10 raised to 27 Ni63 per meter cube. Yun po ang C2 natin. So, i-insert lang po natin sa formula. Magiging negative dc times C2 minus C1 all over X2 minus X1 equals to negative 1.6 times 10 raised to negative 13 meters squared per second times 41.15 minus 42.87 times 10 raised to 27 Ni63 per meter cube all over 4 minus 0 times 10 raised to negative 6 meter. So, insert lang po tayo ng mga given. At ang magiging sagot po ay 0.69 times 10 raised to 20 Ni63 per meter squared. So, how many Ni63 atoms per second through cell? So, magiging sagot po natin ay J is equal to 0.36 nanometer raised to 2 minus Ni63 all over S for the second. Continue. Where can we use fixed law? So, saan nga ba nagagamit ang fixed law? So, fixed law is commonly used to model transport processes in foods, clothing, biopolymers, pharmaceuticals, for soils, semiconductor doping process, and etc. Kung kanina po may steady state diffusion, ngayon po may non-steady state diffusion. So, ano pong pinagkaiba nila? So, sa concentration profile po nila, ang non-steady state diffusion po ay nag-change with time. Tingnan po natin yung box. Yung J left po, tapos sa J right, yung concentration po sa box po ay nag-change. Continue, yung po dj over dx, siya po ay equation galing sa J right minus J left over dc na is equal to negative dc over dt. So, by applying Fick's first law, J is equal to negative d times dc over dx, magiging dj over dx is equal to negative d squared c all over dx squared. Ito po ay mag-apply lamang if d does not vary with x. So, ang pinaka-equation po natin ay dc over dt is equal to d of times d2c all over dx squared.